The TCGS-SEQUENTION framework operates on a strict premise. Reality is anchored in a complete, four-dimensional counterspace. It has no temporal dimension. There is no ontic timeline, no unfolding past or future, just a static, timeless geometric structure. Yet in our operational three-dimensional reality, the domain TCGS calls the shadow, things happen. Batteries discharge. Biological organisms metabolize food. We record a continuous sequence of physical changes. If the ultimate source architecture never evolves through time, we have to explain how energy can be transferred, stored, or consumed in the shadow. The contradiction disappears when we examine how we talk about physics. We intuitively treat energy as an ontological substance, a glowing material fluid that sloshes from one physical container to another. Energy is a purely mathematical functional. It is an objective Noether charge, a strict accounting mechanism assigned exclusively to the registered three-dimensional configurations we observe, not an ingredient of the four-dimensional source. Reconciling quantum behavior with relativistic geometry demands exact mathematical typing. We have to strip energy of its fluid metaphor and treat it entirely as structural accounting. To prevent category errors between the 4D source and 3D observations, the framework relies on a rigid mathematical firewall. We must separate the territory from the map. Step 1 is the complete source configuration, designated chi. This exists entirely within the counterspace. Step 2 is the informational organization of that source, a non-experiential translation of the raw data. Step 3 applies the extrinsic constitutive law profile. This is the specific mathematical map allowing that source content to become readable across the boundary into our observable domain. Step 4 is the selected readout, the precise slice of that data being accessed by an observer or instrument. Step 5 is the physically registered shadow observable. This is the actual physical phenomenon, the real-world carrier we can measure. Step 6 is the observer-assigned energy functional. Energy appears nowhere else in this hierarchy. It only enters at the final step, after physical registration. It is an assigned calculation, distinct from counterspace and the laws that translate it. This functional definition of energy forces a strict re-evaluation of Noether's theorem, which ties conserved quantities to continuous symmetries. In a timeless architecture, you can relabel the mathematical slices, the foliation parameters, of a 4D space any way you want. That arbitrary mathematical gauge freedom does not produce physical stationarity. True energy conservation requires a rigorous set of conditions in the shadow: physical action symmetry, defined equations of motion, and perfect closure of flux across a boundary. We construct operational clocks and track time based entirely on these physical boundary records. Time is a shadow metric, not a hidden axis in counterspace. Conservation laws hold because they are structural properties of how the shadow registers data. They do not require a literal, ontic timeline to enforce the rules. The popular reading of E equals mc squared suggests that matter acts as a physical piggy bank, holding a vast deposit of energetic substance waiting to be released. This is a category error. The m represents mass. In the TCGS framework, mass is the projection-stable invariant of a complete physical carrier. It is the structural footprint the system leaves in the three-dimensional shadow. The E0 is the reference indexed energy counter for that exact same configuration when measured in its rest frame. The constant C remains the invariant null constant. It serves as the geometric projection ratio between the source and the shadow, rather than the speed limit for an energetic fluid. When a particle and antiparticle annihilate, no fluid leaks out of a shattered container. The complete four-momentum balance is simply re-expressed through a different admissible carrier, like radiation. The equation translates two differently typed readings of one identical physical configuration. It connects an invariant structural scalar to an observer's energy functional. Placing standard physical effects, like superconductivity or the Hall effect, into TCGS vocabulary is necessary for compatibility, but it does not supply independent empirical proof for a four-dimensional architecture. We can see this boundary limit by testing external models like quantized inertia. Modifying boundary geometry absolutely selects different spectral energy modes. However, a variance in a Hamiltonian state is a statistical spread of possible measurements. It is not a hidden, extractable reservoir of energy. Relying on variance as a fuel source lacks a conserved current mechanism, and the foundational Compton mass calculation proposed by quantized inertia contains a clear 2π mathematical inconsistency. We find a similar requirement for strict typing in chemical catalysis. Standard models often picture a catalyst lowering a mountain-like energy gradient. A catalyst actually restructures the admissible transition paths in the shadow. It opens a specific topological corridor, increasing the target flux fraction without altering the source counterspace. Theoretical compatibility with existing chemistry or quantum mechanics is the baseline. To prove its structural maps, the framework must make differential predictions that are genuinely capable of failing. A theory insulated from failure produces no new knowledge. TCGS mandates specific cross-domain predictions that must outperform standard baseline models. In electrochemistry, the framework formally withdrew its proposed path dominance index. That early metric attempted to combine whole-cycle energy efficiency with the parasitic loss fraction, packing incompatible denominators into a single flawed scalar. It is replaced by two strictly typed predictions. First, early variance in interface resistance must predict later cell degradation. Second, targeting interface stability must yield longer cell life than simply increasing bulk conductivity. Both claims are testable against current battery standards. We apply this exact requirement to complex ecological systems. To test if specific biological interaction corridors dominate a network, we look to historical predator-prey records. This scatterplot analyzes the Hudson Bay lynx hair pelt returns. Tracking the dominance index against local variability requires specific normalization and lag choices, yielding an R value of -0.054. The second scatterplot tracks the Isle Royal wolf moose population. Because the system suffered known disease outbreaks and severe winters, accurate modeling requires independent perturbation covariance. The baseline output here is an R value of +0.058. The paper explicitly classifies both of these coefficients as null pilot results. At the current resolution, they neither prove nor refute the proposed dominance relations, and the framework refuses to spin weak correlations as support. This strict evidentiary firewall ensures that successful models survive rigorous baseline comparisons, and null results are recorded faithfully. The map is updated, the territory remains untouched. Recalling the strict six-step mathematical chain, we see that the TCGS framework survives entirely by what it excludes from counterspace: electromagnetic transport across a power grid, chemical reactions in a battery, and the physical interventions we make are entirely real, but they represent the accounting rules of the three-dimensional shadow. They are not fluids bleeding down from a four-dimensional source. Stripping away the substantialist metaphor forces an exact, mathematically typed architecture. It requires researchers to isolate their variables, demand tight boundary conditions, and test falsifiable predictions across multiple domains. The mechanics of the universe do not rely on an invisible, material energy fluid flowing through the gears. The ledger of reality balances perfectly through geometry and structural invariance alone. Precision in our mathematical language provides our only accurate map to the territory.